So welcome to part four of our climatic risk video series. Right. So for part four, what will we be looking at? We'll be looking at the nature of climatic hazards with regards to and its influence on climatic risk itself. So earlier on, we talked about Katrina and the impact and how certain factors may actually accentuate or may help buffer against the impact of natural hazards and consequently give the area a higher or lower climatic risk score. So when you're looking at this area, one thing to remember is also you're looking at different types of climatic related hazards, things like cyclones and floods, which bring a lot of immediate impactful impacts, right? And then there are also things that take a longer period of time for it to rear its ugly head, things like sea level rise, things like drought, which have a protracted impact duration. So when you're looking at short-term events, okay, climatic hazards, short-term climatic hazards, things like cyclones and floods, right? They're very sudden, they're very short, they don't last for a very long time. There's massive impact, massive damage, massive pain and suffering in the immediate period following its arrival. Okay, it can lead to widespread destruction of properties, lives, and services, and it's very, very hard to do evacuation for short-term events like this, right? You can have pre-warning, right? A cyclone doesn't appear overnight in front of your doorstep, right? It takes time to grow. It will increase in its power, in its ability to do damage as it approaches the coast itself. You do have time, but very often it's not more than a couple of weeks at best. Okay, so one of the kind of interesting kind of data that you can be given when you are answering questions is a stimulus that looks like this. So this is actually a map showing you the pathway of a particular cyclone as it moves around the region here. Okay, as it's actually exiting, right? As it's actually exiting the Indonesian islands and moving away towards Australia, but not really bending towards the northwest of Australia. It's moving out actually into the Indian Ocean, right? As it disappears. Now, when you're looking at this kind of map, okay, showing movement of tropical cyclone, a couple of things to note. First and foremost, point of origin in the diagram. Where exactly is the start of this cyclone, right? What are the clues? I think the most common one is, of course, you look at it, there's a date, right? So it cannot be moving from the 8th to the 7th to the 6th because time doesn't travel in reverse, right? So you're not in an episode of Loki, so it does move forward. So you will always look at the first date where this thing is being tracked. Okay, it doesn't mean that it suddenly appeared there. This is actually the the period of time where they are starting the tracking. Okay, where it was near Timor Leste and it moved away. So 5th April, 5 o'clock is the first marker. Okay, first marker, right? So direction of movement, right? Please bear in mind, there is no north arrow given here. However, you do have the reference points of Indonesia and Australia, and in this relationship, you should know as a geog student that north is facing up. Okay, this is essential knowledge that you must know. You do not need to memorize all the countries and where they are on the map, but you need to have a general understanding of where north would be in regards to countries, especially countries that are near Southeast Asia, where we reside. Okay, direction of movement very important. So it's moving in the southwest direction, right? It's moving to the southwest, right? So key points of change: did it increase in intensity? Did it decrease in intensity? Right? Where do we read intensity? You look at the number, right? So number one is the most impactful. As it moves away, it actually loses intensity, right? So it becomes category 2, category 3 as it moves further and further away from the islands itself, right? Is there a change in direction? If there is, you need to note that change in direction. How do you note that there's a change in direction, right? Which day it started moving in a different direction. How do you know which day? How do you know what time? Look at the data that's given to you in the map. Okay. Other things that are given in the data, intensity, date, timing, these are important in your description. They will also generally give you some other information if they would want to test your ability to pick this information out. and answer a subsequent question. So things like how many people affected, how many people displaced. So bear in mind, displacement versus affected. These displaced people are a subset of the affected people, because if you are displaced, you're affected. But there are also people who are affected, they are not displaced. Displaced means you lose your home. So there are 30.7, there are, yeah, 30,000, over 30,000 people affected by this tropical cyclone. But only 500 over are displaced. The rest of them could be injured, could have economic, social losses, but they are not displaced. Okay, 59 dead. Are they affected? Yes, they're dead. Right? Injuries. Are they affected? Yes, they are. Are they displaced? We don't know. Okay. 42 missing. Missing also is affected. Missing is also affected. And then your homes, 800 over homes damaged, but only 563 displaced. Means the damage doesn't mean complete destruction. Okay, so these are things that you need to learn to pick out when you are looking at a particular data set given to you. Okay, so typical question would be like this: describe the movement of tropical cyclone Seroja as it moved from Indonesian islands towards Australia in the figure. So once again, this figure is the same. So like we mentioned earlier in the earlier slide, right? Start point, end point, direction, date, timing, all these need to be tracked and all these need to be mentioned. Do you need to mention all the points that are here? Because actually there are 7 points here. Okay, you don't really need to. What are the essential ones that I must mention? I must mention when there's an increase or decrease in intensity, a change in direction. So 5th April to from 5 to 7 p.m., right? 1700 to 1900 hours, right? That I have to mention. I will have to mention that it stays the same for how long? Maybe for a day, right? Because you look at the category, the intensity actually stays at category 2 all the way until 6 April, 7 p.m. again. Then from that to the next morning, 7 April, 7 a.m., there's the further decrease in intensity. Direction doesn't change, so mention direction, mention that there's a decrease in intensity, and then that holds for another day. Okay, so bear in mind, this is only describing movement. So this chunk over here is not used for this part yet. Sometimes it will not be used. Okay, so bear in mind, sometimes information is given in as distractors, right? Because not everybody bothers to read the entire question, they just plunge in, right? And that's a horrible thing to do. Okay, so sometimes things like this, these are distractors, they're not meant for you to process for this question. Second thing to talk about is, of course, duration of the climatic related hazards. If it is a long-term event, so it's not a sudden one, right? Why is it that floods are sudden, droughts are not? Because it takes some time before all the moisture is lost, and then you start to feel the impact of droughts. So droughts is a long-term event. Same thing for sea level rise. Sea level rise occurs not overnight. Okay, you don't go to bed the next day. Oh, my kneecaps are covered in water, right? It doesn't happen like that. It takes time. So when you're looking at this, it has a longer period of time. By right, these risks can be delayed, and these risks would be easier for people to plan and mitigate for, or adapt to at the very least. Okay, but there are certain things that are hard to make adaptations for. So I give you an example. If your sea level, the sea level rise is going to come in, it may rise up to up to a meter where you're living. Okay, you're living in a very low lying area, it may rise up to 1 meter. What can you do to prepare for this? Within your lifetime, it will raise to 1 meter. What will you do to your house? Is it possible for us to remove the house, put the house on stilts? Right? What are the economic costs for this? So it isn't always the case where you look at the situation that's presented to you and you wonder, hey, this is a long-term event. Why do these people not do anything about it? It's not that they don't want to. Okay, so I need you to be very clear about this. It's many a times not that they don't want to, it's that there is no affordance for them to do that. Okay, so keep this in mind when you're looking at long-term events like sea level rise and droughts. Okay, so this is another type of chart that you may encounter. This is a line graph, right? So it actually shows continuous data. Previously, we talked about how line graphs are really good for temperature, right? For temperature, actually, if you are holding any sort of continuous data that you want to show the increase and decrease clearly, right, and there's no break in the data set, this is a good type of graph to use. So we can actually use it to track global sea level across this period time frame here. This is over 2,000 years, or no, close to 2,000 years, close to 2,000 years, right? So when you look at this, you can actually see the increase, and you can see the very sharp increase from the 1800s. Why? Because of Industrial Revolution, we started pumping consistently more and more CO2 in the environment. So if you look at this part of the graph here, you can see that it is what it is. Okay, it's going to rise a lot more. Right. So when you're describing this, once again, what are we looking for? General trend. General trend. Okay, in this case, it's fluctuating until the 1800s, where it embarks on a very steep increase. Right. So the first part here from 400 BC all the way until 1800, it is fluctuating. You see ups, you see downs. Okay, but it actually fluctuates around between 0 and 5 centimeters. Okay, only at 1800 it starts to take a very steep jump. Okay, now when you're fluctuating, right, you do need to give a rough idea. So you need to figure out it's fluctuating around what degree. Okay, or you can tell me a range fluctuating from 0 to about 10. 0 to about 10. Okay, so this is useful in terms of your description. Endpoint, where are we? And we're at in the year 2000, we are near 20 centimeters. That's very serious, right? Think about it. Okay, an increase of 15 centimeters or about 14 centimeters from what it was originally tracked before 400 BC. Okay, are there other descriptors? Things like fluctuating, okay, is a descriptor. Things like steep increase, steep rise, these are descriptors that help a person visualize what this is. Okay, are there details that are important? Okay, is there a particular area where there's a plunge, a very serious plunge, a very serious jump before the final jump? Would you want to report that? Okay, now the hint to answering describe questions clearly is this: describing something for someone means that person doesn't have access to this graph. What you want the person to form in his or her head is this graph. So when you have finished or we've completed your description of the graph, what do? You cover the graph, you read your description, and you try to sketch something out based on your description, based on your narration of what you see in the graph. And then compare those two. What is missing, you need to add into your description. Okay, details that are missing, right? You're not trying to give them a one-to-one replication of the graph. Okay, you don't have time for that in an exam, but you are trying to give them enough information for them to reproduce this graph in a general sense. Okay, showing the more important points. That's why we talk about important points that you want to highlight, right? Because those are points that you want them to be able to see in their head, and when they reproduce the graph, produce one that's more accurate. Okay. So typically what do you have? You have things like this, 4-mark questions describing change in sea level from calendar year 1000 to 2000. So 1000 is only here, right, to 2000. The rest you ignore, okay? So once again, your question will many a times include disclaimers or areas where they want you to focus on in the data set. So what happens if I do the entire graph here instead of 1000 to 2000 only? Then whatever is described before will be ignored. So can you imagine 4 marks if you have to describe the whole range versus 4 marks you have to describe 1000 to 2000? What are the details that you have included, or what are the details that you have excluded? Okay, because it's 4 marks, right? So you have to be very careful when you're dealing with questions. You have to answer to the question itself. Okay, so keep that in mind. Short term, long term. Okay, now we're going to look at communities' access to water, food, and health as resources. Okay, and how this will impact readiness for climatic risk. Okay, so earlier on we talked about I gave you an example of like water, right? So similarly, let's look at access to healthcare. So if you think about it, your community is poor, right? The government is unable to provide good, consistent, and available healthcare. what happens when you have a disease? Okay, what happens when you are sick? Will you be as productive at work? Will that impact your salary? Because your boss look at you, wow, you cannot work at all, you're super inefficient, you're sick half the time, you're on sick leave all the time. So then your income will get affected. Okay, so this will then again limit your actions and your behaviors to cope with climate change. So it's a vicious cycle like this. Okay, similarly, when you look at the component of food and water, you don't have enough food and water, your body's immunity level will be much lower, so you become more susceptible to infectious disease, and then that will again reflect in terms of productivity at work. Okay, so take a close look at this graph or this diagram here, this flow chart here, I'm sorry, right? And this shows you how these different factors actually work together to make a vicious cycle. Okay, in terms of systems, likelihood to being exposed to climatic risks, right? Not all natural systems are durable. This is something you need to know. Some of them are like your more needy friends, okay? They need a bit more care, more concern. But yeah, so it really isn't, it's like us, right? Right. So the nature ecosystems, they are all of different hardiness. Okay, so one very needy one and very not very hardy one would be corals. Okay, corals need optimal temperature, optimal clarity, so that there is sunlight that comes in and they can do some form of growth. They cannot be too cold, cannot be too hot, it cannot be too salty, so it cannot be not salty enough, right? So salinity is another big problem. Okay, so if there are in extreme weather conditions, all these things are swung out of control, right? What happens to the corals? They die. Okay, they go through bleaching, which we talked about in the earlier video, and it dies. Now, having the natural coral system die, right, is one problem because it affects your food chain, your marine food chain. But immediately when your coral system dies, it no longer is as beautiful, as big, as massive, as impressive. The other area of impact is tourism. So there are many coral areas that around the world that are tourism hotspots. Okay, because they're very beautiful, so many tourists come to these areas and engage in this kind of tourism. Okay, so an idea of what kind of monetary value we're looking at, right? If you think about the Great Barrier Reef, okay, over time, right, annual amount that's churned is in the billions. So this is very serious. Can you imagine all this is lost suddenly? Okay, right, exposure, right? How would exposure impact you? Coastal and dry environments again, like we mentioned earlier, dry environments, they are already in dire states in terms of water. So any more impact in terms of removing even more water or introducing anything else, they are in a more sensitive and fragile state. Okay, similarly for coastal environments, you are in direct face, facing full force of climatic hazards. Now, climatic hazards tend to need water for it to happen. Okay, either they remove water or there's too much water, and then it tends to be near water surfaces. So when you're coastal, generally is a bad idea. Okay, because you are exposed to more things like storm surges, floods, sea level rises. This can all affect you. So you take a look at a township like this, right? Can you imagine if there's sea level rise? Okay, they're on top of a cliff, right? Literally, this is on top of a cliff. So if there's a sea level rise of maybe 10 meters, they may still be safe. Okay, but the ones in the background, look at this in the background here, right? All these 10 meters will all be submerged already, right? They're all submerged. Then what about the access road to the houses that are on the cliff? So keep that in mind. It's not only whether the house is safe. Okay, when you have storm surge, what about all these things? Same thing. Storm surge is when the storm pushes the waves inward and you have flooding. Okay, inland flooding because of storm surge. So, and if you look at, let's look at big countries, huh? Let's not look at island nations like Singapore. If you look at a big, huge country like America, it still has, at times, coastal areas. So when you're looking at continental USA, right, which is the main block itself, not Hawaii, which areas are the ones that are at risk to coastal hazards? All the ones on the west and east coast. Okay, so some of you may have had west holidays on the west coast, where you go to LA, you go down to Frisco, right? Or you go to New York on the eastern coast. These are all actually at risk. These are all very big cities and they're all coastal cities. So imagine what happens when there is a storm surge, or when there's a tropical cyclone that comes. Okay, or in America, they don't call them tropical cyclones, they call them hurricanes, right? So, example we learned about earlier was New Orleans with Katrina, right? So, this is what we're talking about when we're looking at Katrina. Okay, why is it at high risk of coastal hazards? Because it's on the coast. Timbuktu, right? You heard people, I'm going to send you to Timbuktu, right? Timbuktu is actually a real place. It's in Mali, right? Actually, it has a lot of things not going for it. It has got very, very dry climate. Um, Water is scarce. There's underground water, but it's hard to get by. So it's very easy for locations like this to fall into droughts. Okay. Now, mitigation strategies, right, very important. How does it how effective are they, right, in building community resilience? Actually, it requires your community to change, okay, how you actually use your energy and land, right? It will not stop. Let me emphasize this. It will not stop global warming. All these strategies of mitigation only seek to slow down global warming and allow the systems, be it nature itself or humans, to adapt. So mitigation, right? You take a close look at the hard words I've highlighted. Number one, it will not stop. Okay, number two, it will slow down, and the poor function of mitigation strategies allow us to adapt, to give us time. It's basically buying time. Okay, so what can it do for us? It will allow us to resist for a while, adapt, and then recover from the impacts of all these disasters. So this is the function of mitigation strategies for us. Okay, so I will stop here. The next video will continue on about mitigation strategies, some of the ones that are being used. So go and watch the video on Katrina if you have not done so, and I'll see you in the next video.